Suppose I give you the following problem. I want you to design a method that, if we give it a list of numbers, then it will return a new list where all of the negative numbers are removed. Okay? So, I mean, this is a fairly straightforward method, and I'm pretty sure we've actually written something like this before. But let's just go ahead and do it very quickly. So it receives a list of integers, and then we can create a new list of integers with the property that we want. Okay? So we're going to loop over every integer in the list, and then if it's positive, then we're going to keep it. Okay? So let's assume that 0 is positive, so we'll keep it. And there we go. So let's just output this list and see what we get. So it should be 42, 81, 101, 0, 2. So basically it has the negative 3 and the negative 4 removed. Okay? So of course this is not a comprehensive way of doing this. You should always use JUnit and test multiple things. But that's not really the point I'm trying to show here. Okay? So suppose I then give you a different question. Let's say I want you to, if you're given a list of numbers again, I want you to remove all multiples of 10. Well, then, I mean, all we have to do is just sort of copy this method, remove multiples of 10. Then we just say, if it's not a multiple of 10, so if we divide it by 10 and the divisor, or the remainder is not 0, then we add it to our list. Okay? So then we can just call it here. And of course, this should return the list of, let's throw in a multiple of 2 there. Or a multiple of 10, sorry. So this should return the list of everything without the 0, the 40, and the 0. Okay, and indeed it does. So now let's say I give you another question and I say I want you to write a method that removes both negatives and multiples of 10. Well, then again, we can just copy this and then say remove multiples of 10 and negatives. Okay? Then if we say that it's not divisible by 10 and it is greater than or equal to 0, then we add it to the list. So we can just copy this. And this should remove the 3, the 4, the 0, the 40, and the 0. And it does. Okay? But hopefully you kind of see what the issue with this is. So we're defining multiple methods that all kind of do the same thing, which is we filter out something. We filter out elements based on some property. Okay? So we filter out elements based on a property. And this sounds like something that perhaps we could write a method to do for us. And indeed, we could do this. Well, we can't really do it at this point because we don't know what interfaces are. But there is something that we can take advantage of. There's a method called, so remember .map? There's another method that's very similar. It's called .filter. And what we do is we give it something called a predicate. Now we've talked about predicates before, and a predicate is just something that returns a true or false value. Okay? Returns a true or false value. So the way filter works is when we call it on a stream, we pass it a predicate, and that predicate will filter out elements that do not satisfy the predicate. So for example, if I want to filter out all negatives, all negative numbers, then I will say that the predicate receives a value in, and it will return, or it will keep all numbers that are greater than or equal to 0. Okay? It will keep all numbers greater than or equal to 0. So if the numbers in this stream satisfy this predicate, the number will remain in the stream. Or rather, it will produce a new stream with this property. Okay? And then if we want to, of course, run the operation, or rather force it, we can use a terminal operation like toList. Okay? So now let's see if this runs. And indeed, it does. Okay? So we filter out the -3 and the -4. Okay? And just for the sake of completeness, let's do the other. So removes multiples of 10. So we want to keep all numbers that are not divisible by 10. And it works. And then we can combine them. So you can not only do single things, but you can also combine them with the logical connectives, for example, and or. So if we want to say we want to filter out multiples of 10 and negatives, then we can just combine this with n is greater than or equal to 0. Okay? So hopefully this makes sense, and the nice thing about this is we can actually combine both map and filter. So for example, let's say we want to, let's get rid of these first off. Let's say that we want to design a method that will square all the numbers in a list and then remove all of the, I don't know, all of the, let's say the perfect squares, okay? So, actually wait, no, that doesn't make sense. I don't know, let me think of a problem real quick and then I'll come back. Okay, so here's just an odd thing that I came up with. So let's say we want to cube all of the numbers in a given list, add 5 to all of those numbers, and then remove all of the odd numbers from that resulting stream. Okay? So, of course, we can just do this in one line. So let's do return ls.stream, and then we're going to call .map on it to apply the cube operation. So it's going to receive a number n. That's going to return n times n times n for that cubing operation. And then we can do .map again to, of course, receive an integer. And then we're going to add 5 to that integer. Okay? And then we're going to do .filter, which is where we're going to remove all of the odd numbers. Okay? But what that means is that we want to keep all of the evens. Okay? So you always have to think in terms of the negation of what you actually want the list to, or what you want the stream to contain. Okay, so we're going to say the predicate receives an integer n, and then it will remove all the remove all the odd numbers. So we're going to keep all the evens. So if n mod 2 is equal to 0, then we will keep it. And then finally, we can just convert this into a list. Okay. Now it's important to note that we could just combine these two mapping operations into one, because we can just say apply the cube and then add 5 to that result, and then we don't need this second one. But I split them up just to make it very clear as to what's happening here. But you don't have to do that. You could obviously combine them into one. Okay, so let's apply this to the list up here. So again, this is not comprehensively testing this, and you should always write JUnit tests for these types of methods. But for the sake of the example, we're just going to show it through printing it out. Okay. So this list is actually kind of hard to tell. So what I think I'm going to do, and in fact, I'm a little curious as to, actually no, never mind, I'm not curious. So let's do this with smaller numbers. Let's say we want to call it with cube add 5, remove odds, list of 1, 2, 3, 4, 5. So this should get us, should be, well, 1 cubed is 1, and then add 5, that would be 6. 2 cubed is 8, and then we add 5, so that would be 13. 3 cubed is 27, so if we add 5, that would be 32. 4 cubed is 64, so we add 5, that would be 69. 5 cubed is 125, plus 5 is 130. Okay, so we remove the 13 and the 69 because those are both odd. Okay, so this video was talking about the .filter method and how it lets us keep elements that satisfy a given predicate. Okay, remember, you have to remember that order. Okay, it keeps elements that satisfy the predicate. Okay, so it filters out things that do not satisfy the predicate. Okay, and .filter is also a filter is also an intermediate operation, just like map, which means that it returns a stream, and it will not do anything until you force it with some terminal operation.